for this section is variables on both sides. For the section, we'll still use absolute value equations. Solving these will have variables on both sides of the original equation. For the section, the same definition or something to keep in mind for all absolute value equations is always check solutions. Again, by checking solutions, verifying the answer still works, but again, on some absolute value equations, all the work can be correct when you're solving the equation, but when you check solutions, the answer will not work and will be eliminated as a possible solution. First question we'll solve is 3 times the absolute value of p minus 5 equals 2p. Again, for these questions, we will have variables on both sides of the equations. Before we solve absolute value equations and have the two equations with the two possible answers, the absolute value must be isolated or by itself. So in this case, the 3, we need to move to the other side. This is 3 times the absolute value. So we can divide both sides by 3 to cancel out or move the 3 over. P minus 5 stays the same inside the absolute value, and we'll have a fraction 2/3 p. To solve from here, when the absolute value is by itself, again, you can take the absolute value signs off, p minus 5, and set it equal to 2/3 p. The second equation we can solve, p minus 5 would stay the same. But again, instead of equals 2/3 p, we'll do the opposite, which is negative 2/3 p. And again, we'll do the opposite because if the absolute value is equal to negative 2/3 p, then the absolute value answer would still be 2/3 p. Solving the original equation, we can subtract p on both sides. That way the variables all go to the right hand side. Negative 5 would stay the same. 2/3 p minus 1p. You can get common denominators on those. 2/3 p would stay the same. And instead of minus 1p or minus p, you can change 1 into 3/3 or minus 3/3p. Negative 5 stays the same. And now we have common denominators. 2/3 minus 3/3 would be negative 1/3 p. To get rid of a fraction, negative 1/3 times p, we can multiply by the reciprocal. Reciprocal of negative 1/3 would be negative 3/1, which will multiply on both sides. Negative 3/1, or just negative 3, times negative 5 would be 15. The right hand side, the 3's would cancel, the 1's would cancel, and the negative cancels. So the reciprocals cancel out, and we're just left with p. So again, one possible answer to the first equation is 15 equals p, or p equals 15. The second equation that we had written earlier, equal to negative 2/3 p. Same steps, we can subtract p on both sides. Negative 5 again stays the same. And again, we'll need common denominators to subtract fractions. Negative 2/3 p would stay the same. And negative 1 we can change into negative 3/3 p. Solving from here, negative 5 stays the same. Negative 2/3 minus 3/3 would be negative 5/3 p. solving from here to get rid of a fraction that we're multiplying by, you can always multiply by the reciprocal. Negative 5/3, the reciprocal will be negative 3/5. And we'll multiply that on both sides. Multiplying negative 3/5 times negative 5. Negative 5 you can make a fraction. Negative 5 over 1. You could multiply and then divide. You can also cross cancel the 5's. The negative would still be left, but 5's would cancel. So we have a negative 3 times a negative, which would be positive 3. Multiplying the right side fractions. Again, you could multiply straight across and then simplify. Or a little easier method, we can cross cancel the 3 with the negative 3. But again, the negative would still be left. And we can also cancel the negative 5 and 5. But again, the negative will still be left. So we'll have two negatives, like two negative 1's. Multiplying those, that would be positive. We have a p left, so that would be positive 3. So again, our answer or possible answer, 3 equals p, or p equals 3. Always again to double check answers on absolute values, or two possible answers. Make sure you double check by plugging back into the original equation to verify that they work. First answer 15. If we do 15 minus 5, that would be 10. Absolute value of 10 would still be 10, times 3 would be 30. So the left hand side would equal 30. If you plug a 15 into the right hand side, 2 times p, 15 times 2 would be 30, and 30 would equal 30. So the first answer, 15, does work. If you check the second answer, 3, plug a 3 into the absolute value. 3 minus 5 would be negative 2. Absolute value of negative 2 is positive 2, times 3 would be 6 for the left hand side. And plugging a 3 into the right hand side, which was originally 2p, 2 times 3 would be 6. So 6 equals 6, which is true, which means the answer is also true. So two answers that do work, 15 and 3. Second question for the section, and last question. Equation is 16y equals 4. Inside absolute value, 3y plus 8. Again, for the section, we have variables on both sides that we'll be solving. Absolute values, before we solve, the absolute value again has to be isolated by itself. So in this case, the 4 we have to move to the left-hand side. Again, this is 4 times the absolute value. Opposite of multiplying by 4, we can divide both sides by 4. So our equation would be 4y. The 4's would cancel on the left, and we'll have 3y plus 8 inside absolute value. Once we have the absolute value again isolated, we can solve two equations from here. First equation, 4y would stay the same, and you can remove the absolute value signs, 3y plus 8. For the second equation we'll solve, instead of positive 4y, the number or term outside the absolute value, we'll change that to make it a negative 4y. And again, what's inside the absolute value stays the same, but you can remove the absolute value signs. Solving each equation, 4y equals 3y plus 8. We can subtract 3y on both sides. 4y minus 3y would be 1y or just y. 3y would cancel, and we have the answer, or again possible answer, y equals 8. Second question, or second equation that we have on the right hand side. Same steps, we can subtract 3y on both sides. Negative 4y minus 3y would be negative 7y. And again, the 3y's would cancel on the right hand side and equals 8. Solving from here, negative 7y. We can divide by negative 7. So the negative 7's cancel. And our second possible answer will have a fraction negative 8 over 7. Keep in mind these are two answers or two possible answers. To verify that they work, we'll want to plug them in back to the original equation. On this question, one of these answers will not be a solution. To check which one, I'll rewrite the original equation. 16y equals 4 absolute value of 3y plus 8. Our two possible answers, y equals 8 and y equals negative 8 over 7. We'll plug in the 8 first. 16 times 8. And for 3y, which would be 3 times 8, and plus 8. 16 times 8. If you multiply that out, it comes out to 128. 4 stays outside the absolute value. 3 times 8 would be 24, and plus 8. 128 stays the same. 4 would stay the same. 24 plus 8 would be 32. And 128 equals, the absolute value of 32 would still be 32, and times 4 is 128. 128 equals 128, which is true, which means this answer, y equals 8, does work and is a correct solution. The second possible answer, y equals negative 8 over 7. Again, we'll take the same original equation and plug in negative 8 over 7. So we'll have 16y, but instead of y, we'll have negative 8 over 7 equals 4 times the absolute value of 3, negative 8 over 7 instead of y. And plus 8 inside the absolute value. Solving from here, 16 times negative 8 over 7. The 16 you can make a fraction, 16 over 1, and then multiply straight across the numerators and denominators. 16 times negative 8 would be negative 128, and 1 times 7 would be 7. The right hand side, 4 would stay the same. 3 times negative 8 over 7. Again, 3 we can make a fraction by putting a 1 for the denominator. 3 times a negative 8 would be negative 24, and 1 times 7 would be 7. Plus 8. Instead of plus 8, we want common denominators for the next step. So the 8 I'll change to 8 over 1. And to get common denominators, we can multiply this fraction by 7 in the numerator and 7 in the denominator. 8 times 7 would be 56, and 1 times 7 would be 7. Solving from here, negative 128 over 7 stays the same on the left-hand side. 4 stays the same outside the absolute value. And combining fractions, negative 24 over 7 plus 56 over 7. 56 minus 24 would be 32 over 7. Negative 128 over 7 stays the same on the left-hand side. 32 over 7, the absolute value would stay the same. Multiplying by 4, we can change the 4 to a fraction, 4 over 1. And multiplying 4 times 32, that would be 128. And 1 times 7 would be 7. Negative 128 over 7 does not equal positive 128 over 7. So in this case, our solution at the top was a correct solution for the equation that we solved, negative 8 over 7. but upon verifying, plugging that number back in, checking the solution, it does not work, which means y equals negative 8 over 7 is not a solution for this equation. And our only answer would be y equals 8. Title of the last section today is Writing an Absolute Value Inequality. For these questions, we'll be looking at a graph and working backwards to write the inequality. First question, we have a number line with negative 4 on the left-hand side, 0 in the middle, and positive 4 on the right-hand side. Above negative 4 we have an open circle, and above positive 4 we have an open circle, and we'll connect the 2 points in the middle. Having the graph of this inequality, we can figure out what the original inequality was. To do that, we know it's an absolute value inequality since we have two numbers. So we can start with an absolute value. We'll have a variable, we can use x, and the number next to x that we'll subtract is the number that's halfway between negative 4 and positive 4. So halfway between the endpoints would be 0, so we'll subtract 0 inside the absolute value. The inequality, when the 2 points are connected in the middle, the inequality is always less than, and since they are open circles, it's not less than or equal to, it's just less than. And the number it's less than is the distance from the center to either outside point. So from 0 to 4, that is a distance of 4, so it will be less than 4. Simplifying this, x minus 0 would just be x, and our final answer would be the absolute value of x is less than 4. Second question, and last question for the section. Again, we'll have a number line. This question will have negative 4 on the left-hand side and negative 2 on the right-hand side. The point above negative 4 will be closed or solid. The point above negative 2 will be closed or solid. The line for negative 4 goes to the left, and the line for negative 2 goes to the right. Same steps as above. We know it's an absolute value inequality because we have 2 points for the inequality. So we'll start with an absolute value. Using a variable, we can use x. We'll always subtract a number. The number we subtract again is the number that's halfway between our two endpoints. The number halfway between negative 4 and negative 2 would be negative 3. So we'll subtract a negative 3. When the lines point away from each other, that would be greater than. And since both points are closed, that would be greater than